Sherpa Enterprise Framework is a versatile Sherpa Designer template that can be foundation for many RPA projects. Its implementation is highly recommended for process automation, especially for unattended automations. It is very easy to access it. When creating a new project in Sherpa Designer, select to start with Enterprise Framework project. But let's start with the basics. Business processes are very different, but they can be categorized by how they approach the repetition of steps in data processing. Singular processes, linear. Steps are performed once. For new data instances, the automation is started over again. For example, an incoming email triggers the process of automatically replying to the email. This type is suitable for individual cases, but not for multiple iterations of data processing. Repetitive processes, iterative. Steps are repeated for each typical element in the dataset. This process is performed in a loop. The disadvantage of that, if an error happens, the whole process stops, leaving some elements unprocessed. Task-based processes. Similar to iterative processes, but here each item is processed independently as a separate task. Tasks are discrete and autonomous. According to the framework, a task must contain a minimum unit of processing information, and once processed, this piece of data is considered unnecessary for the rest of the process. While the Sherpa Enterprise Framework is typically used for queues-based unattended automations, it is suitable for a variety of scenarios. Attended and unattended business processes. Input data from queue of Orchestrator or other sources, for example, Excel and email. Linear processes. Let's get back to the main topic of this video. Sherpa Enterprise Framework is a Sherpa Designer template built using state machines. It is the starting point for the development of RPA projects, especially those that require scalable data processing. It is built with all best practices in mind regarding configuration, logging, exception handling, application launch, and allows you to implement any business scenario. Simply put, the Sherpa Enterprise Framework is that basic template for developing new automation that you would come to on your own if you decided to create a thoughtful and reliable system that minimizes errors and halts in the process. And if they occur, it tries to resolve them automatically without losing data or progress. And if a process stops due to an error, it localizes the problem and reports in detail. The main diagram in the Sherpa Enterprise Framework project is like a body of any queue-oriented process, though it can be adapted to any task. Here you can see several pre-created states. States are defined circumstances of an algorithm's execution. Depending on certain conditions, execution can move from one state to another, representing process stages. In the main diagram, these are the states of initialization the process, retrieving the task from the queue of Orchestrator, processing, and terminating the process. You can also see how states are linked together, what validations are performed at the end of a state, and what happens in case of an exception. It looks pretty self-explanatory, especially if you pay attention to the comment blocks. Once we have dealt with the main diagram, I propose to dive deeper into the initialization state. This state starts the applications required by the process and loads the configuration table file. The data from this file is stored in dictionary and then used in parameters for functional blocks. Therefore, you can tweak the process operation without making any changes to it, only to the table. And this is considered good practice. The table is divided into sheets by type of information: settings, constants, assets, and credentials. Each worksheet has 3 columns: for the name in the dictionary used to refer to the value itself, and its description, the text that lets you understand the purpose and contents. The initialization states create a dictionary with all the names and values, and you can refer to them using the config name variable and additional functions. You can see that the initialization state diagram contains checks, logging, transitions to other diagrams, and of course exit points from the state. When reached, the process will continue from where it entered the state. In our case, back to the main diagram and the next block that guides the process depending on the success of the previous state. If the required applications are successfully started and the configuration file is read, the process moves on to the getTestData state, where you retrieve the test data from Orchestrator. Or you can reconfigure state to get a data item from another source, such as a table. GetTestData and processTest states, unlike initialization, are included in the iterative part of process, because it is often necessary to process several data items and continue until there are none left. Besides the standard iteration path where the process has successfully handled the task, there are two exception handling tracks. If a system exception occurs, for example an error due to a frozen application or a timeout caused by network lag, the process jumps back to initialization state, which includes closing the applications involved in the process and restarting them. The process then returns to the same task on which the system exception occurred, if it has not already been processed by another robot and is still in a queue in a suitable status. Business exception usually cannot be solved by retrying. Such cases require human involvement, so the task that caused it gets a business exception status and is no longer handled by this process.